What's your email address again?
Right there?
Okay, yeah.
This is actually the most direct. This is the one I use the most. I do have a second email address on my digital math tutor website, but that gets forwarded to this one and it takes longer. So if you're sending stuff, this is the best one to use. Pictures and stuff. Sometimes it can take a half an hour if you send it to the other email address.
Yeah.
These generally come in pretty quick, though.
Yeah.
So what was that first question?
So the first question I need help on is, it says name each equilateral, parallelogram, rectangle, rhombus, and square for which the statements are true. I need help on 21, which says its diagonals are perpendicular.
And the question is it equal angular?
No, so you have to like name, so no, question 21 says its diagonals are perpendicular, and I have to find out if that means it's a parallelogram, a rectangle, a rhombus, or a square.
Okay. So if we had a square, clearly the diagonals are going to be perpendicular.
Yeah.
Okay. If we had a parallelogram, the diagonals still look to be perpendicular. Even if we make a parallelogram like this, now the diagonals don't look perpendicular, but it may just be because my drawing is inaccurate. So they don't appear to be perpendicular for a parallelogram.
Yeah.
Square, parallelogram, rhombus. Rhombus is just a 4 equal-sided figure.
Yeah.
So rhombus could be parallelogram.
Which
means that they're not going to necessarily be perpendicular for a rhombus either.
Yeah.
Oh, excuse me. Hold on a second. A rhombus is not necessarily a perpendicular. It can't be this. In other words, my rhombus could be this, and it looks like they might be perpendicular. And in fact, a diamond is a rhombus. If I make a diamond or a kite, that's a typical kite, and the diagonals are perpendicular for a kite, and a rhombus is a kite with equal sides. In other words, in my drawing here, that side's not the same as that side, but if it was a rhombus, they would be the same. Okay? And the diagonals of a kite are always perpendicular, so the diagonals of a rhombus must also be perpendicular.
Yeah.
All right. I still have not received that. Did it send?
Yes, it did.
Wow. You sure you sent it to David Cowan, COWAN, 1949 at gmail.com? Did you leave off the 1949 perhaps, or spell it COWEN?
I spelled it the same and put the numbers in.
I'm betting that there was something slightly wrong. I've run into this 24. Can you check? In other words, check your sent and see where you sent that email.
Okay.
There's no spaces. In other words, it's all one thing. David Cowan, 1949 at gmail.com.
It said it's sent. It said just sent.
Okay. Yeah, now it came in. All right.
Okay.
All right. Close that out. Minimize that. Let me open up these things here.
Okay.
The first page or the second page?
The first page.
Okay.
Yeah. That.
And you want to start with the first page, right?
Yes. Yeah, that page right there. Yeah. And so we just did 21. So I also need help on 23.
Okay. Name each quadrilateral for which the statement is true. Okay. You don't need to do 19 or 20?
No, I already did those.
Okay. So 23, the diagonals bisect one another. Which ones does that have? Well, I'm not sure I have this memorized. Obviously, for a parallelogram, let's see if they do. And the way to figure these out is always exaggerated. Don't draw your parallelogram like a rhombus.
Mm-hmm.
Draw it like that. They do.
Mm-hmm.
Okay. For a rectangle, they do.
Okay.
For a rhombus, now this time I'm going to draw the rhombus kind of like a parallelogram with equal sides. Well, I already know they do for a parallelogram, so they must for a rhombus.
And they will for a square as well.
And they will for a square, but they don't for a kite, notice. You've studied kites, right?
Mm-hmm.
For a kite, one of them is bisected, but the other one is not.
Yeah.
That's equal to that, but that is not equal to that. So, but, okay. So that answers 23?
Yes, yeah. And then 24.
Okay, the diagonals bisect opposite angles. Well, obviously for a square they do.
Yeah.
Because you create 45-degree angles.
Mm-hmm.
And for a rectangle, let's draw a really long rectangle. That is not going to be a 45-degree angle.
Yeah.
So they don't for a rectangle.
Mm-hmm.
Okay. That's the only one we haven't. Parallelogram. If I draw a really long parallelogram like that, they appear to.
Mm-hmm.
And I think they do. And we could prove they do. How? We would have to prove that this angle is equal to, well, we'd have to prove that that angle is equal to this angle.
Mm-hmm.
And we can certainly prove that 1 is equal to 2 because the parallel nature of them.
Yeah.
But proving 1 is equal to 3, in other words, we know 3 is equal to 4. I don't believe they do.
Okay.
I'm not aware of any theorem that says they bisect the opposite angles.
Yeah, there's not a theorem that we've learned.
Yeah, the only thing we know here is that 1's equal to 2 because the parallel lines, and 3 is equal to 4. And we do know that that whole angle is equal to that whole angle.
But we don't know if 2 equals 4 and 3 equals 1.
Yeah, I don't think they do.
Okay.
I'm trying to figure out if I draw a really long one, whether it would become more apparent. It looks, in the picture that I've drawn, it looks like 3 is bigger than 1.
Yeah.
Not that that's the way to solve geometry problems by appearance.
Yeah.
But a lot of times it's a good way to figure out whether, you're right or wrong.
Yeah.
All right, let's go on.
Okay, and then 25. I don't know what went wrong with this one.
Okay, if that's a rectangle, then we know that that angle plus that angle equals 90. Not that that angle is equal to that angle.
Okay.
Their
So
error is assuming they're equal. Remember, the diagonal on a rectangle does not bisect that angle.
Yeah.
Okay, so I can't assume that that angle is equal to that angle, which is what the assumption they make is. What I would have to say is that 7x minus 4 plus 3x plus 14 is equal to 90. And then solve that. What do I get? 10x equals 80. X equals 8.
Okay.
Open up the next page.
Yep.
I thought I did this once. I did. I already had it open, sorry. Begin with which one?
Let's see here. Which ones do we have? 44. Is 44 on that page?
Uh-huh.
Okay, yeah, 44.
Okay, this is a square.
Uh-huh.
Okay, what is the measurement of MKN? That angle right there.
So it would be 90 degrees?
Yeah, remember that when we were answering that question about the diagonals being perpendicular? They are for a square. So if those two lines are perpendicular, each of these angles is 90 degrees.
Okay.
What is LMK? This angle right there. We also know that the diagonals bisect the opposite angle.
Yeah.
So what must each of these tiny ones be?
45.
Correct. So that's the answer to 45 is 45. LPK is what? This one right here.
That's also 45.
Okay. The length of KN. This is a side where, oh, okay. Well, they're giving us this. I thought we were going to have to use geometry to figure it out, but we don't. They give us that's 1. What's this one?
That's 1.
Also, because we also know they bisect one another.
Yeah.
MP?
MP is 2.
Okay, and here's the hard one, LP. In other words, if that is to the diagonal, and this is a 45, 45.
Yep, and then 90.
So what is LP? What is this side right here?
Would it be, like, the measurement would be 1.
No. There's two triangles that's really worth knowing their dimensions. One is your 30, 60, 90, and the other is a 45, 45, 90. Now, when I teach this, I generally teach the unit one as 1, 1, square root of 2. Okay?
Okay.
Well, this is a similar triangle, but the hypotenuse is 2 instead of square root of 2. So, how do I get the sides?
No, you wouldn't square root 2.
Well, the first thing you'd want to do is find out what the similarity ratio is. This triangle is bigger. Its hypotenuse is 2. This hypotenuse is approximately 1.41.
Okay.
Okay? So, let's figure out a similarity ratio.
Okay.
Take the bigger one, divide it by the similar side of the smaller one. There's the similarity ratio. Everything on the bigger triangle has to be this much bigger than it is on the unit triangle.
Okay.
So I'm going to take my measurement of 1 and multiply it by 2 over square root of 2. Okay? Well, 2 over square root of 2 has one problem with it. It's not rationalized. So we got to rationalize it by multiplying it by square root of 2 over square root of 2. That gives us 2 square root of 2 over 2. That's what x is, square root of 2.
Okay.
You understand my algebra when I went through that?
Yes, yeah.
In other words, this triangle is similar to this triangle. So each side has to be proportional. Whatever the proportion of the hypotenuse is, the same proportion has to exist in this side relative to this side. A lot of schools actually, when you get into trig, they will teach you this triangle on the left as the basic one, instead of this one. Because when you start dealing with sines and cosines, the hypotenuse is always in the denominator, and it comes ready rationalized if you use this picture. I prefer this picture over here because I like to think of it as the unit triangle. And unit being the opposite side is 1. And the other really important one is this one. And you do yourselves big favor by memorizing these proportions. Everything you see on my page right now. That will come up so frequently over the next 3 years for you. That you just want to memorize what you're looking at. The fact that you're looking at a 30, 60, 90, the fact you're looking at a 45, 45, 90, and what the dimensions of each are. Doesn't really matter whether you use square root of 2, square root of 2, 2 over here, or whether you use 1, 1, square root of 2. All problems begin by figuring out the similarity ratio and then going from there. Okay, and is all you need to figure out the similarity ratio is to take your measurement and divide it by your basic triangle. So it doesn't really matter whether I multiply everything here by square root of 2, which is what they've done in this problem, basically.
Yeah.
All right, what next?
I think that's the last one, unless did we, I think you said. Okay. Yeah, that was the last problem that I had questions on.
Okay. I don't know if this was meant to be a half-hour session or an hour session, but it's fine with me if we...
It was a half hour.
Okay, cool. If it's a half-hour session and I don't have anything following and you still have material you want to cover, I'm fine with that. In other words, it's okay with me if you schedule a half hour and want to go 45 minutes or an hour. I can always do that, assuming you don't have something right after you, which is the case today. So just know that when you're scheduling. If you know you have an hour's worth of material, definitely schedule for an hour. If you're not sure, it's also okay with me if you schedule for an hour and you want to stop at the end of a half hour. I have no problem with that either. Okay?
All right.
And I'll only charge you for a half hour. I won't charge you for the hour.
Okay.
So I guess what I'm really saying is if you want to be safe, if you're not sure, schedule an hour, and then we can always cut it short if need be.
Okay, I think we went over all the material I had questions on.
So that's fine for today. The only thing I need from you is your email address to send you a link to the recording of this. In other words, all of the online sessions are going to be recorded, and I post them to YouTube, and then I give you a link to that particular session that allows you to watch it again in YouTube format, which means you can fast forward, rewind, pause, and all of that.
Didn't you send you my email already?
Well, you maybe did in the sign up. Let me check if it's in here. Is this it here? CMKNKM? Or is that your dad's?
Yes, that one will work, or the email she just sent you with the pictures that we just went over today.
Okay, you're right. I forgot you just sent me some pictures, so I can send it to either one. So I do have your email,
Yes, yeah.
Okay, and normally if it's a really busy day, it takes my computer all night to process these, so I don't get it uploaded till the next morning. But in this particular case, it should be up there within a couple hours.
Okay.
And I'll send you the link to it when it's up. Okay. Kristen, you have any questions about how all this works, or Mr. Matuzensky?
Sure. Yes. Yeah, this was good. This is our first, the first half hour after.
Yes. Okay.
Last week. So, yeah, we'll.
Sounds like you're all set to go. I noticed that you made payment and everything, so you figured out how everything works.
Yeah.
If you're going to use PayPal, I don't know if you use Digital Math Tutor or Algebra to Calculus Tutor. For PayPal, it's actually a little bit easier on your end to use Digital Math Tutor. They both go to me, but I've made the interface just a little smoother on Digital Math Tutor, so that you don't have to go send a payment to my email address.
Oh, okay. Okay.
Yeah, you'll like it. It's a little easier if you use digitalmathtutor.com.
Mm-hmm.
And you can use Digital Math Tutor to schedule. It's the same scheduler, regardless of which one you're on. Okay?
Okay. Well, we'll set up another session, but we're going to find out when our next quiz is, and then a couple days before set up a session. Okay?
Sounds good. Kristen, have a good rest of your weekend, and I'll talk to you next time.
Thanks, you too.
Bye-bye.